the block 5 atomic physics. So block 5 atomic physics, it's a short topic and it is somewhat similar to chemistry as well. The structure of an atom, a structure of an atom consists of the nucleus. Inside the nucleus, the particle which are present, neutron and protons, and around the nucleus, another subatomic particle, electrons are revolving around. And region where these electrons are revolving, the space that is known as orbit or shell. So the central part, the core of the atom, is known as a nucleus. Around the nucleus, the region where the electrons are revolving, we call that as orbit or shell. Inside the nucleus, we have particles such as neutrons and protons. And collectively, this neutron and proton, the collective term which we use for both of them, we call the nucleon. Like neutron and proton collectively are known as nucleons. The term nucleon is the term which is used like the particles which are inside the nucleus, so we can say nucleons. So when we represent any atom, symbolic representation of any atom, it can be represented by symbol of that element. A is a nucleon number or mass number and Z is a proton number, or Z can be up, so Z is a proton number and A is a mass number. Like we have lithium, when we write lithium, Li. So when we write lithium, which is Li, and write 7 at the top, so for lithium, we write 7 at the top and 3 at the bottom. So what is the nucleon number, A? What is A here, the nucleon number or the mass number? The nucleon number or the mass number is 7. And what about, so A in this example is 7. What about Z? Z is a atomic number, or we can also say proton number. So what is Z here? Z is equals to 3. And if we want to find for any atom, if we want to find the number of neutron, proton and electron, so the formula which we use to get the proton is given by Z, neutron is given by A minus Z, the difference of mass number and atomic number, and electron is equals to Z minus the charge on atom. Like what is the charge on atom? We'll subtract, we will get that number of electrons. I'll give an example. Example, you have calcium, which is 20 and 40 with a charge 2 plus. So what is A here in this example of calcium? What is the value of A? The mass number. The mass number. Mass number is either equal to or more than the atomic number. So that's equal to 40. So it's not necessary that mass number is always at the top. It can be at the bottom. So mass number is 40. What is Z here? So Z is equals to 20. If you want to find number of neutron, proton, and electrons, so if you find the proton number will be equal to Z, that is equals to 20. If you want to find the neutron number, that is A minus Z, the difference 40 minus 20, that is also equal to 20. And if you want to find electron, that is Z minus the charge on the atom. So Z is 20 here, minus the charge is how much? 2 plus or 2. So 18 minus 20 minus 2, that is equals to 18. So it is having 18 electrons. Is it clear, this example? Then another example, if you have beryllium, which is 4 and 11. So beryllium is there, which is 4 and 11. So what is A here? So A is equals to, A is either greater than or equal to the atomic number. So A is equals to 11 and Z is equals to 4. If you want to find protons, how to find a proton number? Proton number is given by Z. So that is equals to 4. If you want to find neutron, that is equals to A minus Z. So 11 minus 4, that is equals to 7. And if you want to find electrons, that is Z minus the charge. But in this case, Z is 4 and there is no charge. So that is also having a 4 electrons. Then another example, if you have nitrogen, which is 7 and 14 with the charge minus 3. What is A here and what is Z? What is the value of A? A is 14. And what about Z? Z is 7. So A is equals to 14 and Z is equals to 7. How many protons are there? Proton number is given by Z. That's equal to 7. Neutron number is equal to A minus Z, the difference. So it will be 14 minus 7. That is also equal to 7. And to find the electron, it is Z minus the charge. Like what is the charge on the atom? Because when there's a charge on atom, we call that as a 9, either a positive or negative. So Z is equals to 7 minus, and the charge is minus 3. So it will be 7 minus minus plus 3. So 7 plus 3, that is equals to 10. So it will have 10 electrons. It will have 7 protons and it will have 7 neutrons. But sometimes the atoms have same atomic number, but different atomic mass, known as isotopes. So atoms having a same atomic number but different atomic masses, we call them as isotopes. So example, if we write for chlorine, there is 17 and 35. and then there is chlorine, which is 17 and 37. What is A here and what is Z? For the first one, what is A and what is Z? So A is equals to 35 and Z is equals to 13. Sorry, 17. So here in this example, we have A is equals to 35 and Z is 17. For the second example, A is 37, Z is 17. So you can see same atomic number but different atomic mass. So what we call them as isotopes. Or there's also another definition of isotope. They, in terms of subatomic particle, these are atoms with same proton number, atoms of same element. But different neutron number known as isotopes. So when you work out the number of the proton, neutron, not about electron because it does not depend on the isotope. Electron number only affect the charge because there's a loss or gain. How many protons are there in the first one? How many protons and how many neutrons? The first one, chlorine 35 and 17. So basically there are 17 protons, and when you take the difference 35 minus 17, that is 18 neutrons. So 17 protons are there and 18 neutrons. And when you check for the other one, it is having 17 protons, but neutron, when you take a difference 37 minus 17, that's equal to 20. So they have the same atomic proton number but different neutron number, we call isotope. Or same atomic number but different atomic mass, we can also say isotope. So the definition of isotope you have to learn, and identification of from the table. You don't have to learn or memorize any atomic number or atomic mass that will be given in the question. You just have to identify the isotopes, and on what basis you will identify the isotope? On the basis of proton number. Z indicates atomic number, A indicates atomic mass. So A is equals to atomic mass or nucleon number, and Z is equals to atomic number. So they have the same atomic number, different atomic mass, or they have same number of proton, but different number of neutrons. We call them as isotopes. Now, what happened for elements? Atomic number more than 82. So for element atomic number more than 82, it means the proton number more than 82. What we observe, I'm just drawing a nucleus. So this is a nucleus of an atom. And the size of this nucleus is in femtometer. Femtometer means 10 raised to power minus 15 of the meter. That is the size of the nucleus, approximate. Variation is there, but approximate size is 10 power minus 15 of the meter. Now what happened? for elements which are having atomic number more than 82. So means inside the nucleus, what we have the particles, we have neutrons. The black spot is representing the neutron, and we have protons as well. So what we observe as the proton number increase, atomic number increase, or the number of the proton increases inside the nucleus, what kind of force is there between the two protons? They are like charges in which kind of electrostatic force? Attractive or repulsive between the two protons? The like charges repel each other. So as the like charges repel each other, these protons try to push each other. So there are a lot of protons inside the nucleus. So there are a lot of protons inside the nucleus. So elements which are having atomic number more than 82, their nucleus is not stable. Find it difficult to hold neutrons and protons inside the nucleus. So the nucleus is not stable. Why the nucleus is not stable? Like, it is crowded nuclei. Crowded nuclei means there are a lot of protons, lot of neutrons. Neutrons, they're occupying the space. They're covering the space. So they are also limiting the space available for the particle to stay in the nucleus. This is not the atom. This I draw a nuclei or nucleus of an atom. So neutron and proton find it difficult, like the nucleus find it difficult to hold these particles inside the nucleus, and the nucleus become unstable. Unstable means it find it difficult to hold this. So how the nucleus can be stable? How the nucleus can get stability? So how the nucleus will be stable? By releasing the particle. No, not by more. Basically, like neutrons are occupying the space. If you have one room, that room is having example of furniture, that furniture is like example of neutron, and there is a gathering, the people are inside the room. So but if, for example, if the capacity of the room is say 50 people can be there, but if 100 people enter, then what will happen? It create a chaos, like it will not be stable or hold these people inside. Same thing happen, the nucleus find it difficult to hold, these particles inside. So then what it start to do? It start to emit out the particle. The nucleus emits particles and energy, and this process of emitting particles or energy is known as radioactivity. So basically what happened, the nucleus start to gain the stability, the nucleus start to emit out the particle and radiation. There are three type of radiation or the particle emitted out, denoted by a Greek alphabet: alpha, beta, gamma. So the radiation or the particle emitted out by the nucleus to emit to be stable, one is called alpha another one is beta, another one is gamma. We'll discuss what is alpha, beta, and gamma. But first thing, you should understand the fact that because the nucleus is not able to hold particles inside within this small space, so it start to emit out these particles. And when the nucleus start to emit out these particles, this phenomena of emitting out the particle is called radioactivity. And when the particle is coming out, we also say radioactive decay or radioactive breaking. Is it clear till this point? The term radioactivity, what's the meaning of radioactivity, and why the nucleus is radioactive? The nucleus consists of the particles such as neutron and proton. So inside the nucleus, you have protons and you have neutrons. Because there are a lot of protons and neutrons inside the nucleus, so nucleus find it difficult to hold these particles. As the nucleus find it difficult to hold these particles, it start to emit out this particle, and the process of emitting out this particle is known as radioactivity. Like emitting out the particle from the nucleus is termed as radioactivity. And why the nucleus is radioactive? Because how it emit out the particle, because there's a repulsion. Like what happened, you have protons and protons, the like charges are repelling each other. So as protons are repelling, they are pushing each other out, so these particles will go out from the nucleus due to strong electrostatic repulsion. So as these particles will come out, we call this phenomena of emission or coming out of particle radioactivity. And the process of radioactivity is proton. This is not the shell, this is a nucleus. So it will remove or go out from the nucleus, and as well as go out from the atom. Because if I draw the full atom, this is a full atom. Atom consists of a nucleus. The central part is a nucleus, and around the nucleus, electrons are there. So what happened? As there are more protons and neutrons inside the nucleus find it difficult to hold these particles. As it find it difficult to hold these particles, start to emit out. So when they release those particles, these particles will even go out from the atom. When it will stop emitting out radiation, when the atomic number is 82. Because the elements which are having atomic number more than 82 are radioactive, means they are not stable, their nucleus is not stable, it starts to emit out particles, alpha, beta, and gamma, and we call this process as radioactivity. Once it reach atomic number 82, 82 is the atomic number for lead. So once and when the element or atom is emitting out radiation, it's because it is emitting out proton, neutrons, so its atomic number is also changing and atomic mass is also changing, so it convert into another element. So when a radioactivity occur, the identity of the element is also changing. Now 82 is a proton number. It's not the difference, not the nucleon number, because this is atomic number. Atomic number means number of proton. So for elements which are having proton number more than 82, they are radioactive. Naturally, they are radioactive. So for element which are having atomic number less than or equal to 82, less than or equal to 82, those elements are stable element, are not radioactive naturally. So when these particles will escape, the electron will also go out. But in this part, because this is called atomic physics, so in this part you will only learn there is a change in electron also, like emission of electron as well. But in this part you will only learn the changes inside the nucleus. It emits out electrons also from the orbits once it is emitting out the particles from the nucleus, but you are only studying the change, what are the changes happen inside the nucleus. And this radioactivity is a random and spontaneous process. Random means there is no order, and spontaneous means not affected by external conditions. So example, you have 5 radioactive nuclei. These are the 5 radioactive nuclei. First radioactive nuclei first emit out radiation. Then 3 emit out radiation. Next, which one will emit out radiation? First, the nucleus 1 emit out radiation, then 3 emit out radiation. Next will be? Which one will be next? It's a random. In the beginning, I mentioned random means there is no order. It can be anyone. It can be even one can emit out the next radiation. Maybe 5 will emit out. Maybe 2 will emit out. Maybe 3 will emit out again. Maybe 4 will emit out. We don't know. We cannot predict like which will be the next nucleus to decay. It's a random process. It is not having any order. So you cannot predict. So if we want, so we cannot predict which will be the next decay. And same thing, if you have a radioactive nuclei, a radioactive substance. Yes, Afif, you have a question?
Sir, like, can't this depend on like the number of protons and neutrons that are present inside the nucleus? Like, for example, if I assume that atom 5, it has a larger number of neutrons and protons compared to the other ones.
No,
So, like,
that
won't it
in that
really?
case, yeah, in that case, if but what we are considering, all of them are identical. If all of them are radioactive and they have identical number of proton and neutron, then we cannot predict the order. If, for example, if one is another element, a nucleus of another element, and then second, like one is, say, one is polonium, 2 is plutonium, 3 is radon, 4 is thorium, 5 is uranium. So if different elements are there, then we cannot say, like, then it depends on which is more radioactive. Definitely that will emit out radiation. But if you have identical atoms, identical radioactive nuclei, and you want to state like which will be the next one to emit out radiation, in that case we cannot predict. Is it clear?
Yes, sir, it's clear. Thank you.
The second, it is not affected by external condition, so it is spontaneous. What is the meaning of spontaneous? Means it happened by itself. You cannot do, or you cannot change the rate of this emission. So example, if we have a sample So this material is radioactive. This is a whole material. I'm not drawing a nucleus or an atom, like it has many or millions of atoms. And this material is radioactive and it is emitting out 3 radiations. Now I supply the heat energy. Will it affect the amount of radiation, radioactive radiation? Like example, it is emitting out alpha radiation, because radiation can be 3 types: alpha, beta, or gamma. So it is not affected. The temperature will rise. Definitely the temperature will rise. The thermal or heat radiation will increase. But radioactive radiation such as alpha, beta, and gamma are not affected by changing the state, changing the temperature, changing the pressure of the substance. So radioactivity is random and spontaneous. Is it clear the meaning of random and spontaneous? Random means there is no order, and spontaneous means it is not affected by any sort of external condition. Even I can have a radioactive substance at high temperature or at low temperature. Why it is spontaneous? Because the heat which we supply is absorbed by the atoms, and atoms start to vibrate. Like this is a nucleus and this one is a shell. Then there is another nucleus and shell. Then there is another nucleus and shell. So when we supply energy, we are not able to supply energy to the nucleus. Basically what happened, energy is absorbed by the atom and the atom start to vibrate. And when atoms start to vibrate, the temperature of the substance increase. How do we know which radiation rays are emitted? We cannot know, because it is a random process. For random process, there is no order. Like example, if you have a nucleus, first it emit out alpha, then it emit out beta, then what will be the next one? We cannot predict. Why we cannot predict? Because it is a random process. Random process is not having any order, so there is no prediction that I can say that the first radiation was alpha, then beta, and the third one will be gamma. It can be gamma, it can be beta, it can be alpha, or maybe it will not emit out any radiation. So this process is a random process, means it does not have any order. Yes, that can be known. Like we can identify average frequency, not the actual frequency, like how many radiations will be there per second. That can be determined. But that is again, it's not a fixed number, it will be average. Like one is emitting out, say example, 5 radiation, another one is emitting out 3 radiation, another one 7 radiation. So we will take an average number of radiation and we can work out the frequency of the radiation. But we cannot predict which radiation will be the next one. Is it clear? Yeah, it is just like we cannot say exact which radiation will be there, but we can say average number of radiation emitted out from the nucleus. Then what kind of radiation? Radioactive radiations. The 3 radioactive radiations are alpha, beta, and gamma. You should learn the symbol for each radiation. Alpha, this is alpha; beta, like B, a Greek alphabet; and gamma, like R. What is alpha radiation? Alpha radiation means when 2 protons and 2 neutrons are coming out together. A group of two particles, two protons and two neutrons, when they are coming out together, what we call that as alpha. So two protons and two neutrons. And this alpha particle is also known as helium nuclei. Why we call alpha particle as a helium nuclei? Because it resembles with the nucleus of the helium. Because what is helium? Helium is He, which is 4 and 2. So when we write, it contains two protons, it contains two neutrons, and it contains two electrons. So inside the nucleus, we have two protons and two neutrons. And around the nucleus, we have two electrons. But you can see that this part, two proton and two neutron, it resembles with alpha particle. So that's why alpha particle is also known as helium nuclei. This is another name for alpha particle. What is beta? Beta is electron actually. But my question is, in the nucleus, because all of these radiation are emitted from the nucleus. So all of these radiation are emitted from the nucleus, and when I'm drawing the nucleus, I did not draw electron inside the nucleus. All the examples, even from the beginning, I did not draw any nucleus. So how there is a sorry, I did not draw electron, not nucleus. The remaining particles will be there. It is not emitting out all of them. There are a lot of protons and neutrons. So remaining proton and neutron will be there. Basically what happened, there are a lot of proton, like example, you have 84 protons and you have 140 neutrons. So when it emit out alpha, like alpha is two proton and two neutrons. So what you're left with? You're left with 82 protons now, and you're left with 138 neutron. So there are still particles left in the nucleus after emission of alpha particle, which is two proton and two neutron.